In part 6, we use the car evaluation data, which has the following variables: price, maintenance, doors, passengers, luggage, safety, and evaluation is the output variable. First of all, I performed exploratory analysis on the dataset. Then I printed out the unique values to see if there are any unusual values in there, but everything seemed fine here. So I converted the categorical values in there into integer representations, and then printed out the unique values so that I can map with the original values. After that, I separated the input and output arrays into X and Y. Then using the k-means cluster algorithm, we only feed it the input values as it's an unsupervised algorithm. It does not require output values. Then we have our cluster centers here for all our 3 clusters for the 5 variables we have. Here we have our cluster labels for the 3 clusters, 0, 1, and 2. And then here I have plotted my clusters here using a scatter graph. After that, I predicted using this model 2 new records, which can be so. These are the 2 records I used to predict using the model from the k-means clustering algorithm. So the first record was associated with the cluster 1, and the second record was associated with cluster 2. This right here is cluster 1, and this is our cluster 2. My scatter matrix does not show all my clusters properly here. In part 7, I used the clean data set from part 3. In this part, we have to build a model using both the linear regression and decision tree regressor algorithm, and then compare both of them. So I performed the exploratory analysis as usual and did my data visualization. After that, there is one categorical variable in there, which is zip code. It's not actually categorical when you look into it because it's they are integer values, but we need to treat it as categorical. Otherwise, this will affect our analysis because zip codes are actually categories. So I marked them as other integer values. And then I separated the input and output data and split the training and testing data, and then build the model using linear regression algorithm with our training data. You can see the coefficients here for all the variables. Then I calculated the R-square for this model. And then I made predictions for 2 new records, which I'm going to show you in the Word document. Then I did the same thing with the decision tree. Uh, and then I also performed k-fold cross-validation on both of them. And I can show you the results in my Word document. So the R-square score from linear regression was 0.65, and the negative mean square error was minus 47041641052. Uh, uh, and the R-square score from decision tree algorithm was 0.63. So if we compare, the R-square score of linear regression is better here. So we can assume that this algorithm will be more suited to us for our data. Then I use this same records to make predictions using both the models. The linear regressor gave me the price 187,251, while decision tree gave me the prediction of more than 1 million, which is not a very feasible prediction in my view. Similarly, for the second record, I got a good enough prediction from the linear regressor, but uh, again, the same prediction value for the second house as well from decision tree, which is unusual to me as well. So I think linear regression algorithm is better for us in this scenario. In the last part, I again used the same dataset, which is already cleaned from part 3. Here I had to make a change to the output variable price, as price was a range of integer values. But since this is a classification problem, so that's why I converted the price variable into two classes. One with price having less than or equals to $500,000, and the other having price greater than $500,000. So then our price variable is transformed like this. Then I printed out the classification size to check how many records belong to which class. And then I encoded the categorical variable zip code into integer variables. After that, I performed exploratory data analysis and data visualization. Then I separated my input and output values and splitted the dataset for training and testing. And then using the training dataset, I trained the logistic regression model as well as the k-nearest neighbors algorithm. And if we compare the results of the both of them, first, if we compare the classification report with logistic regression, the precision, the difference between the precision is not much significant. Whereas if you see that here there's a slight difference between the precision of both the outcomes. The less than equals to 500K values can be predicted more accurately as compared to greater than 500K. So we can assume that this model is more stable in terms of making predictions. And then if you also see the accuracy levels, then the accuracy level of this model is greater than the accuracy level of the k-nearest neighbor model. And if you also go through the accuracy values from the k-fold cross-validation, it's it's the same for both of the models. We have uh, I use same record to make predictions using both of these different models. I will discuss the predictions in my Word document here. So for this first record, logistic regression and k nearest neighbor, uh, both models provided me with the same outcome, that this record belongs to the class of houses having price greater than 500K. Whereas for the second record, both of them provided me different results. Logistic regression uh, classified as at greater than 500K, and k nearest neighbor classified as less than equals to 500K. So that's it from my presentation. Thank you very much for attending.